Hi engineers, today we will learn how to do earthing calculations using IS 3043. This video covers earth pit calculations using earthing rod and earthing plate. First step is to calculate grid conductor size in square mm. Grid conductor means conductor connecting various panels, DBs and equipment to the earth pits. It can be a wire, a strip or a bare conductor. You can find this formula in IS 3043 page number 30. This PDF file is enclosed with the video. We need to find out as here. I is the system fault current. It can be 10 kA as 50 or 100. Here, we will consider fault current as 36 kA. K is factored depending upon conductor material. We can select the value of K from the chart given in standard. We will consider here copper conductor with 1 second fault clearing time, so our resulting K will be 205. T is the operating time of the device in seconds. We will consider 1 second for our example. By inserting the values of I, T and K, we will get the cross-section area of conductor as 176.61 meter square. We have to select strip size greater than this value. Standard strip sizes are shown. We will select 50 by 6 copper strip as its cross-section area is 300 meter square, which is greater than 176.61. In step 2, we need to find the current density. You can see formula as shown in slide. We will need two things to calculate density. One is operating time of disconnecting device in seconds. That is one we have already considered. And second is soil resistivity. Soil resistivity can be obtained from project specification. It is usually mentioned for the bigger projects. If we do not have the data, we can refer chart provided in standard. Here, we will consider soil resistivity as 150 ohm meters. This is the snapshot of soil resistivity chart from standard IS 3043. By inserting the values of soil resistivity and time, we will get the current density in ampere per square meter. Third step is to calculate the total area of heat dissipation required. We have this simple formula. Just divide fault current by calculated current density in step 2. Our total heat dissipation area will be 58.24 square meter. In step 3, we have calculated the total heat dissipation area. Now we will calculate heat dissipation area of copper strip, which we have selected in step 1, that is 50 by 6 square mm. Here we are assuming strip length is 400 meters. The formula is written on screen. Twice the length multiplied by width plus thickness. We will get heat dissipation area of strip as 44.8 square meter. Next step is to calculate heat dissipation area required by buried electrode. It can be rod or pipe or plate. It can be calculated by subtracting strip heat dissipation area from total heat dissipation area we have calculated in step 4 and step 3 respectively. This heat dissipation area is important as we will calculate total number of pits or conductors to dissipate this much heat. Till step 5, calculations will remain same for rod or plate type earthing. From now, we will do calculations separately for rod type and plate type earthing. You will have to go with either of them as per the project requirement. In order to calculate total number of conductors or pits, first we will calculate surface area of buried conductor. Sizes are specified in standard as shown. Sometime earthing conductor sizes are specified in project specification itself. If not, we can check with standard or sizes available with manufacturer. We will design system with 3 meter by 38 mm rod, and we will consider plate size as 0.6 meter by 0.6 meter with 12 mm thickness. Formula for calculating area of rod is pi dl, where d is diameter of rod and l is length of rod. Formula of surface area of plate is twice the length into breadth. We will get area of rod equal to 0.35 square meter, and area of plate equal to 0.72 square meter. Total number of rods or pits can now simply be calculated by dividing heat dissipation area of electrode, calculated in step 5 by area of one rod. We have just calculated. Total number of pits required to dissipate the heat will be 40 numbers. Similarly, if we are using plates, total number of pits will be calculated by dividing heat dissipation area of electrode by area of one plate. With plate type earthing, total number of pits required will be 19. Our job does not finish yet just by calculating number of pits. We have to check system earth resistance. It should be less than 1 ohm. System resistance will be effective resistance of all pits and grid conductor, that is earthing strip in our case. Formula for calculating resistance of rod and plate is provided in standard. Snapshot of the same is attached in video. While inserting values in formula, care has to be taken with the units. Have a look at the formula for calculating resistance of rod. Length and diameter of the pipe are in centimeters while resistivity is in ohm meters. Similarly, you can see values are inserted in formula for calculating the resistance of earthing plate. After calculating the resistance of single rod and plate, we have to calculate total pit resistance. As number of pits are 40 in case of rod-type earthing, we will divide resistance of one rod by 40. We are dividing as conductors are connected in parallel. Similarly, resistance of one plate is divided by 19 to get total pit resistance. Now, we will calculate resistance of earthing strip. Formula for strip is same for both rod and plate type earthing. Snapshots of formula are shown in video. Please note we are assuming depth of burial as 60 cm and length of strip required is 400 meters. Care must be taken while inserting the values. Length and depth of burial are in centimeter while resistivity is in ohm meters. We are getting strip resistance equal to 0.954 ohms. Now we have pit resistance and strip resistance in both the cases. We can check system resistance by calculating effective resistance as shown on screen. Total resistance obtained in both the cases is less than 1 ohm, so we can finalize number of pits as calculated. If the system resistance is more than 1 ohm, we can increase number of pits and recalculate pit resistance from step 7. Increasing number of pits will definitely decrease pit resistance, and in the end overall system resistance. We have to keep checking resistance by increasing number of pits, till we get overall resistance less than 1 ohm. Hope you are now aware with the procedure for calculating number of pits. Earthing Standard IS 3043 is attached with the video. Page numbers of subject formulas are mentioned in the video for the ease of finding.